Okay, today we'll be talking about section 3.2, part 2. So we're still talking about the same trig integrals that we talked about before. We're also going to add in the product to sum formulas into some of these integrals. The double angle formulas are also going to be in here again. And the Pythagorean identities, so make sure that you know all of those. Also, the angle reduction formulas. Sorry, power. Call them the power reduction. There we go. The power reduction formulas for sine squared of u is equal to 1/2 plus 1/2. Let me make sure that's right. Nope, the sine is minus. So 1/2 minus 1/2 cosine of 2a. And then the power reduction formula for cosine squared of u is equal to 1/2 minus 1/2 sine of 2u. Okay, so those are our power reduction formulas for sine squared and cosine squared. Down here a little bit further, we have the reduction formulas for secant and for tangent. So this is also out of the book. So you can go into the OpenStax website, section 3.2, and scroll down. You'll find the reduction formulas for secant and for tangent. Okay, so go ahead, write those down. Pause this if you need to get those written down. In example number 1, you can see that we have a trig equation with some other stuff. So we're just, for this part 2, we're just still using these same trig equations and formulas, but just adding a little bit more into it. So in this case, I've got a lot going on here. I'm going to go ahead and substitute u. Substitute u for x cubed. And then du is going to be 3x squared dx. And so therefore we don't have a 3 in here anywhere. So let's divide that 3 out. So we've got 1/3 du is equal to x squared dx, which we do have an x squared and a dx. So those will all become 1/3 du. So let's rewrite that now. I'm going to pull the 5 out as well. So now I have 5/3 times the integral of sine squared u. Yep. And u. Yep. So that worked out just great. So now what we're going to do is we're going to go ahead and use that angle reduction formula for sine squared. So now we end up with 5/3 times the integral of 1/2 minus 1/2 cosine of 2a. Sorry, we're using u. 2u du. Okay, I'm going to factor out a 1/2 from there. And so now I'm going to have 5/6 times the integral of 1 minus cosine of 2u. So that's great. That gets me way down to a very simple equation to integrate. So I've got 5/6 times u minus 1/2, integral of cosine is going to be negative sine. No, positive sine. So sine of 2u, and then plus c. Okay, now we're going to substitute back in for u, and I'm also going to multiply that 5/6 through. So I have 5/6 x cubed minus 5/12 sine of 6x squared plus c. And let's make sure we're good on that one. 5/6x cubed. Yep. Oh, nope. What happened to my... Okay. Oh, I see what I did. Okay, I plugged in the wrong thing for you. I knew there was something wrong there. Okay, so this is not going to be 6x squared. It's going to be 2x cubed. Okay, glad I checked that. Okay, so we're going to get 2, and then u is x cubed. I did the other u, right? Right? Yep, everything else is good. Okay, and that's our final answer. Okay, for example number 2, we are going to integrate from 0 to pi of sine of 5x times cosine of 9x dx, and we are going to use the, what did I do? The product to sum rule that says if we have sine of A times cosine of B, that equals the sine, oops, sorry, 1/2, the sine of A plus B plus sine of A minus B. Oh, whoops. That was lovely. There we go. Plus sine of A minus B. Okay, so let's go ahead and apply that to this problem. So we've got the integral from 0 to pi. Now let's say 5x is A, 9x is B, and I'm going to pull that 1/2 out in front. So I've got 1/2 times sine of A plus B, which is going to be 14x, plus the sine of A minus B, which is negative 4x, and then dx. Okay, and that gives us a fairly simple problem to integrate. Also, remember the property that says that the sine of negative x is equal to negative sine of x. I'm also going to do the same thing here. So let's rewrite that one more time. We'll have the 1/2 times the integral of 0 to pi of the sine of 14x, and then minus the sine of 4x, and then dx. Okay, so let's go ahead and integrate. So now we have 1/2 times 1/14, and then when we go from sine back to cosine, that's when we're going to get our negative. So negative 14 cosine of 14x minus 1/4, oops, 1/4, and then again negative cosine. So I'm going to change my sign there, negative cosine of 4x, and that's all multiplied by 1/2 and evaluating from 0 to pi. Okay, so now I'm going to multiply that 1/2 all the way through. I'm also going to plug in a pi. So I will end up with negative 1/28 cosine of 14 pi plus 1/8 cosine of 4 pi minus that, all of that same things, but now we're going to plug in 0, so negative 1/28 cosine of 0 plus 1/8 cosine of 0. And then let's look at our unit circle here. For cosine our unit circle is our x values. So at 14 and 4 pi, those are always going to end up being back here at the same as 2 pi, just going around 2 or 7 times in these cases. So our cosine is going to equal to 1 for both of those. And that's also going to be the same for cosine of 0. It's going to equal 1. So we're going to end up with negative 1 over 28 plus 1/8 minus negative 1 over 28 plus 1/8. So we have the same thing, subtracting them, answer is going to end up being 0. Okay, example number 3, now we have a cosine integral between negative pi and cosine squared of 7x. One thing that we can do that I see right off here is we're going from negative pi to pi. So remember that property that says that we can do 2 times the integral from 0 to pi? That will save us a little bit of time in the end, maybe. Okay, also let's go ahead and substitute u for 7x, since we've got a lot of other things that we're worried about here. And then our du would be equal to 7 dx, which we do not have a 7 for that, so let's go ahead and divide that 7 out. So we have 1/7 du equals dx. Okay, other thing that we are going to do, let's go ahead and rewrite first before I add in too much. Okay, 0 to pi cosine squared of u du. Oh, and we've got a 1/7, right? Yep, 1/7 we've got to pull out here too. So make that 2/7. Oh, excuse me. So 2/7 from 0 to pi cosine squared of u du. And now let's go ahead and use that power reduction rule. Remember the power reduction rule that we talked about at the beginning of class. For cosine squared of u is going to be 1/2 plus, right? 1/2 plus 1/2, yes. Cosine of 2u. Okay, so we've got a 2/7 out in front. 0 to pi is our integral. And now instead of cosine squared, I'm going to have 1/2 plus 1/2 cosine of 2u du. I like to pull that 1/2 out, so that's going to give me 1/7 times the integral of 0 to pi. So I factored out a 1/2 from here. We'd bring a 1/2 out here in front. The 2's would cancel. We'd be left with 1/7. And then what's left inside here would be 1 plus cosine of 2u du. Now we can integrate. So we've got 1/7 times u plus, that's going to become 1/2 sine of 2u. And we're evaluating from 0 to pi. We need to substitute back in for u. Ooh, did I miss? No. I think we're good. Okay, I'm going to go ahead and multiply the 1/7 through also. So now I get 1/7 instead of u. U was 7x plus 1/2 sine of 2u. Nope. I want to plug in my u. So sine of 2 times 7x. Okay, evaluated from 0 to pi. I'm going to simplify a little bit, but I'm going to plug in pi and 0 as I go. So that's going to equal x, which is pi. So pi plus 1/2 sine of 14 pi. Okay. Minus, and then we're going to plug in a 0, so we'll just have 0 minus 1/2 sine of 0. Okay, on our unit circle this time, we are looking at sine, which is our y values on our unit circle. So pi is going to stay there. We'll still have the pi, but sine of 14 pi, again, is going to be